Hi all, this is the lecture on correlation and regression. These two tools allow us to look at the relationship between two numeric variables. So every analysis will have an independent variable as well as a dependent variable. The independent variable is what we use to predict which is x, and the dependent variable is the predicted value, which is y. In an ideal situation, the researcher would set the values of the independent variable and then observe the response of the dependent variable. So in this example, we're looking at reaction times for the number of beers the person had. So for 0 beers, the first person who has drank 0 beers has a reaction time of 9/10 of a second. And then the other person that drank 0 beers has a reaction time of 0.95 of a second. And then so on until 6 beers. Reaction time was measured by a machine that rings a bell that clocks the time a person moves their hand from one button to another. The first thing we're going to do with this is a scatter plot, and this is our data in a scatter plot. And what we're looking at is our independent variable on the horizontal axis, which is the x-axis, and then our dependent variable, which is reaction time in this case, on the vertical axis. This is our y. And if you notice here, you could almost draw a straight line on the dots, and that would mean we have like a tight fit, which is what we're looking for. Linear relationships can be categorized in two ways: a deterministic relationship, which is one in which X predicts Y precisely. An example would be sales tax. If you're using the price of an item to predict the sales tax, if you know the tax rate, that's precisely. There's no guessing in that case. And then a probabilistic relationship is one in which we have, in our example, X may predict Y, but it's not going to be perfect. We cannot use the number of drinks someone has to predict with 100% accuracy their reaction time. This is the type we use a lot in statistics, and this is what we're interested in this course. And then the next thing we look at is correlation coefficient, which measures the strength and direction of the linear relationship between two variables. And just like we had x bar is the best estimate for mu, and s is the best estimate for sigma, and p hat is the estimate for p, this is another statistical parameter pair. The sample correlation being the best estimate for population correlation, which the sample correlation is denoted as R, and it doesn't matter if it's lowercase or uppercase. And the population correlation is denoted as rho. That's a Greek letter. So we want to use R to estimate rho. Correlation can be between -1 and 1. So it should not be out of the range of -1 and 1. A positive correlation would mean as x increases, y increases, just like our example in this data right here. If you remember from algebra, a positive slope means if you look at the graph from left to right, it's increasing, so it increases. A negative correlation is a negative slope, so just the opposite, just like this example. An example of negative correlation may be the amount of alcohol before a test. If it's a lot, then the scores will be lower. So now let's talk about the magnitude of those values. Any correlation that is near zero is a weak correlation. Correlation near the ends, -1 or 1, is a strong correlation. And exactly -1 or 1 is a deterministic relationship. So this scatter plot here does not show any relationship. It's very weak. There's no relationship. The correlation coefficient is negative 0.0116, which is close to 0. So again, that's a weak correlation. So one thing you need to be careful of is correlation is the linear relationship between two variables. If you have a relationship that's not linear, like the one here, correlation coefficient does not do a good job in recognizing that. So here we see that there's a strong relationship between the two variables, and we get a weak correlation coefficient since it's not linear. So here's our weak correlation coefficient. So in general, it's important to look at the scatter plot of the data so you don't miss the overall relationship between the two variables. Correlation coefficient should be accompanied by interpretation. So here's the output for my stat lab, which I have shown example videos. So make sure you look at them how to get this output. For the example, we got a correlation coefficient of 0.9432. So that's where the correlation coefficient would be on my stat lab. That's a positive relationship since it's a positive number and it's close to 1, so it's a strong positive relationship. If in the population the correlation is 0, that means that there will not be any relationship at all. So what we're going to do is do a hypothesis test using R as a point estimate for a row and see in the population that there is a non-zero linear relationship. Keep in mind a correlation of exactly 0 means we assume there's no linear relationship. Anything other than 0 means there is a linear relationship, which could be weak or strong. From the StatCrunch output, we get the test statistic and the p-value. And so we look under the parameter estimates, this table right here, and we ignore the intercept, but we go to the slope row, and here's our test statistic and then our p-value right here. So our test statistic is 9.8359 and our p-value is less than 0.001. And just like we have always done, we reject H0 if the p-value is less than alpha. So using alpha equals 0.05, our p-value is less than 0.05. So we reject H0, and there's sufficient evidence to include what the alternative says, which is there's a linear relationship between x and y. So now that we determined that there's a linear relationship, let's describe that relationship. If you remember from algebra, the equation of a line is y equals mx plus b. In regression, they state it as y equals a plus bx. And a would be the intercept term and b would be the slope. So if we look at, again, the StatCrunch output, it tells us the regression equation right here. And for our example, the slope and the intercept have nice interpretations. The intercept is the predicted reaction time for 0 beers. So what that means is we would expect for someone that has 0 beers to have a reaction time of about 1 second. So that's right here, 1 second. Sometimes the y's in the equation, so like this, may have an apostrophe or even a hat, but I'm not picky about this, and they mean the same thing. So just if you want to use y, that's fine with me. And now you can plot the regression equation on the scatter plot using StatCrunch, and you can see that it's a pretty good fit to the data. If you want to predict the reaction time of a person who has had 4.5 beers, we can use this regression equation and then simply just plug in 4.5 for beers, the number of beers. So if we went back to the equation, it was this and then beers. We just plug 4.5 into that. And then we get 1.4670 as our answer. In StatCrunch, you can also do this in StatCrunch, and I did show in one of the example videos how to do this, but it's not hard just to plug in as well. And again, here's a summary of the StatCrunch output. Up top, here is the regression equation. Here's the correlation coefficient, and then the test statistic and the p-value are here. And that's all you need on this output. And then normally there's a second page in the StatCrunch. You'll see there's an error. You can just hit the error over and you'll get the correlation scatter plot. And then here's a couple things I need to mention. When you do a regression equation, all we have done is look at the trends and describe that trend for the values of x in the data set. So we don't necessarily know that the trend continues outside the bounds of this data set. So we wouldn't want to plug in values outside the range of our data set. So for example, we wouldn't want to plug in, for instance, 50 beers. So a person wouldn't drink the 50 beers for our data. So because they stayed in the range of 6. And then another thing to keep in mind is that it's only in the case of true experiment that correlation proves causation. And then here are several questions I would ask you and answers that I would expect to see. So it would be a good idea to go through the questions and the answers to these. So that's it.